Welcome to Math 30-2, Chapter 4, Section 2, Simplifying Rational Expressions. Now today, we're going to determine a rational expression that is equivalent to a given rational expression and multiplying the numerator and denominator by the same factor and saving on divisible values of the equivalent rational expression. We're going to simplify a rational expression. We're going to explain why the non-divisible values of a given rational expression and simplified form are the same, and identify correct errors in given simplification of a rational expression and explain the reasoning. So, first things first, we have to state the restrictions and then simplify. Now, remember we talked about restrictions and non-divisible values in the last lesson. Basically, the denominator, in this case, 18 cannot equal 0, because we cannot divide by 0. Now I have to simplify this, so both sides are 18. 0. And notice 0 divided by 18 is still 0. Now, the cube can't equal 0, so we have to take the cube root of both sides. And fortunately for us, the cube root of 0 is 0, so a cannot equal 0. So that's our restriction or our non-divisible value. And then we simplify. Now, I'm given by splitting this up. This into numbers and different variables. So, minus 24 divided by 18. You have to be able to simplify that. I'm rather hoping you go, oh, they're even, I divide by 2 first. Or you go, oh, I can divide both sides, now divide by 6. And then 4 drop 3 12. This is minus 4 thirds. And then with a squared and a cubed, 2 a's on top, I can cancel it out. We can cancel 2 of them from below. So we got 1 over a, 4, minus 4 over 3. And the colon. That's how I'm supposed to write it down. Okay? Simplify and write it. Find the non-divisible value, simplify and write it out. Don't forget the non-divisible value. So what I'm going to do is I'm going to pause the recording. I want you to do the exact same thing for this second expression here. Alright? So find the non-divisible value, simplify, and then non-divisible. Come back and read both of your answers. Alright? I figured out that the denominator is 36 times x to the 7. And you see I wrote that in red on the left. 36x to the 7 can't equal 0. By both sides by 36. I get x to the 7 can equal 0. Take the 7th root of both sides. You have the calculator. But I don't have to because what's the 7th root of 0? 0. So the non-divisible value is x cannot equal 0. Then I take my fraction and I split it up into 18 over 36, which becomes 1 over 2. Now, if you want to cheat and plug that into your calculator, 5, math, fraction, and that's the simplest fraction for you. You don't remember how to do that. But I don't like that cheat. And then x to the 4 over x to the 7. Well, I cancel out my x's on top. And then I got 3x down below, so that becomes 1 over x cubed. Or 1 over 2x cubed, semicolon, x cannot equal 0. Alright? So that's most of the problem, not all, but most of the puzzle. So, move on to something a smidge harder. 15x cubed minus 5x over 15x cubed. I'll do this one, and then you guys can do the second one. 3y minus 9y squared over 6y cubed. Now, once again, the non-divisible value, 15x cubed cannot equal 0. But you don't change that. Make that purple if you can. So, divide both sides by 15. X cubed cannot equal 0. And of course, I'll take the cube root of both sides. Cannot equal 0. Now, that's straightforward. What's different? When you look at this, it's x. 15x cubed minus 5x. And oh, wait a minute. I've got two terms added together. I can't factor stuff out easily. or cancel stuff out easily. What I should do is factor stuff out of the top term. So 15 to 5, what's the biggest number I can factor out of there? 5. And then x cubed and x, I can factor out an x. Now, what does that leave me? If you have trouble with this, that's 15x cubed x, which is 3 over x squared. So I should have 3x squared left. And then I have minus 5x. I got the 5x, and then minus 1. And the denominator is 15x cubed. Now can I cancel stuff out of this? Yes, I can. Now that I'm multiplying stuff, it's a lot easier to cancel it out. So 1x becomes x squared. 15 and 5, and divide by 5, that becomes 1 and 3. Now that simplifies to 3x squared minus 1 over 3x squared. And no, I cannot cancel out 3x squared because they don't show up in every term. Okay? And please don't forget your non-permissible value, x cannot equal 0. Alright? So, I'm going to pause the recording. I want you guys to try the second one, and we'll come back and compare answers. Alright, welcome back. Now, 3y minus 9y squared divided by 6y cubed. First thing is look at your non-permissible values with the denominator. 6y cubed can't equal 0. See, I did that on the left in green. That looks like by 6. Take the cube root, y can't equal 0. Okay. And on the right, I realize it's 3y minus 9y squared. I got to factor the top first. So I got 3y minus 9y squared. I realize I can factor out 3y. So 3y is 1. And then 9 minus 9y squared divided by y. Is 3y. Minus 3y and plus 1 here.
Please excuse this interruption. Mr. Kennedy, can you please come to the senior high office?
Right. Now, getting slightly longer and nastier. Now we got to factor top and bottom. So once again, I'll do the top one with you, and then you guys do the second one. So here we go. Denominator. 3m cubed minus 4m squared is not equal 0. What can I factor out of this? Alright. Now notice I want you to factor. Now you got two terms like this, add and subtract, factor stuff out. Now this one sucks, because 3 and 4 I can't factor out. But I do term m. I can factor out an m squared. 3m minus 4 cannot equal 0. Now, we've done non-permissible values like this before. When we're multiplying two terms together, m squared cannot equal 0, or 3m minus 4 can equal 0. So, square both sides. M cannot equal 0. It's 1 non-permissible value. The other term, solve for m. 3m cannot equal 4. 3. And we get m cannot equal 4/3. So two non-permissible values there. Ooh, sneaky. Okay. Now, moving on, I need to factor this, or to simplify. Now, note here, I already did the bottom over here. So I know my denominator is m squared times 3m minus 4. What about my numerator? Well, look at it. I've got 6 and 8 even, so I can factor 2. They also both have an n. So I'm down to 3m minus 4. Okay. Notice stuff cancels out. We have a 3m minus 4 numerator denominator, and we cancel out m. So this equals 2 over m. So far, so good. And don't forget our non-permissible values. M cannot equal 0 or 4/3. Alright? So you see what I did there? Factored the denominator, found my non-permissible values, which something like this is usually 2. And I factored everything and something canceled out. Woo! I mean, good. Now, I want you guys to do the exact same thing, this second one. I'll leave this here for you to look at to get inspired by. And I will give you a hint at the bottom. Notice it's minus 12a plus 12 minus and a plus, which kind of sucks. So, maybe in the bottom you factor out a minus 12 from both terms. Anyway, I'm going to be quiet now. I want you to start working on this. If you get stuck, come back and look at what I did, right? So, good luck. Alright, if you're stuck, and yeah, this one's a little sneaky, factor out a minus 12 from both minus 12a and plus 12, that takes you down to an a minus 1 in hint. Okay? Now, our non-permissible values here, and yes, minus 12 can't equal 0, so we ignore that. But a minus 1 cannot equal 0. Wait, I'm sorry. You do it. Come back and get your answers. Okay, gentlemen. When I factored this one, my non-permissible values a cannot equal 1. And then I looked at my top term, 3a cubed minus 3a squared. I can factor out the 3a, and then a minus 1. And notice I have a minus 1 on top and bottom. They both cancel out. Almost like I planned it that way. Then 3 divided by minus 12 is 1 over minus 4. And yes, if you want to, you can write this as minus a over 4. Whatever. Put the minus sign somewhere I can see it clearly. Alright. That's it for the first part. If you're having trouble with this, look at it again. Otherwise, go on to the next video.